Okay, so let's do one of the easiest things we'll ever do this year. This is easier than sig figs, it's easier than anything in my opinion. Let's make some Bohr models. To do this, there are 4 very easy steps to follow. Number 1, make a small circle, but big enough you can write the letters P and N on the inside. The P is for protons, the N is for neutrons. This is going to be your nucleus. So, to do this, I need shape. Circle. And I need plenty of room, so I'll go like that. Okay. Then I'm going to put P and N on the inside. P, N. Done, done. Okay. Next, I find what period, because we don't call them rows anymore, because you know what a period is. You know the periods are the rows. I find what period the element is in. So I'm going to draw the Bohr model for potassium 40. Potassium is in the 4th period. So I'm going to draw that many circles around the nucleus. These are my energy levels. So let me get out shape again. Whoops. That's my dog making noises. So I have to have 4 energy levels because, again, potassium's in the 4th energy level, or in the 4th period. So there's 1. Let me try to make this a little bit more centered. 2, 3, 4. Next, after I write down the nucleus, I put P and N on the inside of my little circle. That's my nucleus. After I figure out what period the element is in and put that many energy levels around it, I then start filling in how many protons and neutrons there are. For potassium, this was over the summer, so you should know how to do this. For potassium, I look at the atomic number. It's atomic number 19, which means it has 19 protons. Now, for the neutrons, if you remember, we do mass number minus atomic number. And since I gave you a mass number, I specifically gave you a mass number, you need to use this number. If I don't give you a mass number, then you go to the periodic table and round the average atomic mass to the nearest whole number. But since I gave you 40, you have to use the number I've given you. So it'll be 40 minus 19, which is 21. 21. Next, I need to start filling in the electrons. Here's how to do this. Right now, everything is neutral for right now. We can change that later. But it says this. Since I have 19 protons, I need 19 electrons. You're going to start with the innermost circle and work your way out. Now, the rule is you're only allowed to have 2 electrons max on the first energy level. So after I have 2 electrons max on the first energy level, I then go to the next energy level. And I can only have 8 electrons max, because my goal is to get 19 total. Well, I can't fit 19 on the first energy level. I can't fit 19 on the second energy level. In fact, I'm going to stop here. I have 1, 2, 3, 4, 5, 6, 7, 8 electrons max on the second energy level. Now I go on to the third and I keep going. So thus far I have a total of 10. I have a total of 10 electrons. I have 2 on the first energy level, 8 on the second energy level. 2 plus 8 is 10. I keep on going. I need 9 more, but I can't do 9 more on the next energy level because, again, you can only have 8 electrons max on this energy level. Later on, we're going to learn that that's not necessarily true, but that's not till the next units. Don't worry about that. For right now, for this unit, you need to remember the first energy level can only have 2 electrons max. All the rest can have 8. So I have 2 electrons on the first energy level. I have 8 on the second. I have 8 on the third. If you add these up, that's 2 plus 8 plus 8. That's a total of 18 total of 18 electrons. Remember, I need 19. So now I just need 1 more, which I'll put on the outermost energy level. And this is known as my valence electron. valence electrons are the electrons in the outermost energy level. And here's how I can check myself. If you recall, potassium is an alkali metal. It's in family 1. And if you're in family 1, you have one valence electron. And sure enough, I only have one valence electron. So again, 4 easy steps. Step 1, make a small circle, put P and N on the inside. Step 2, find what period your element is in, put that many energy levels around the nucleus. Step 3, fill in how many protons, how many neutrons. Step 4, start putting in your electrons. It'll equal the number of protons if it's neutral. Since I have 19, I gotta have 19, since I have 19 protons, I got 19 electrons, so I'll do 2 on the first energy level, then all the other energy levels can have 8 max. Now, just bonus here, if I was to use an ion, let's say it was potassium with a positive 1 charge. Remember, to have a positive charge, you have to lose electrons. So what would happen would be, I would actually delete this electron right here, and that would be potassium with a positive 1 charge because it lost 1 electron. And now I would have 8 valence electrons from underneath. That's important later on when we get to figuring out why elements combine the way they do. And there you go. That's Bohr models. Too easy.